Hello, geometry lovelies. It is geometry time, and I am Miss Waite, and I am going to be leading you on this journey, this geometry journey. Happy whatever day it is for you. For me, it's a Monday. Here is a little warm-up. Would you please pause this video and work on this warm-up? And then come on back and we'll work on it together. Okie dokie. So we have been talking about polygons, and then we started specializing in quadrilaterals, and the one kind of quadrilateral that we've talked about so far are parallelograms. And so what we know about parallelograms is that their opposite sides are congruent, their opposite angles are congruent, their diagonals bisect each other, and other such lovely things. We're going to be using these ideas to solve these problems. So when we look at these two problems, numbers 1, 2, and 3 deal with the figure on the left, and 4, 5, and 6 deal with the figure on the right, so they're kind of separate. So when we're looking at the figure on the left, notice that we have, first of all, a quadrilateral, because it has 4 sides, therefore it's a quadrilateral. But even better than that, it's a parallelogram, and the reason why I know is because it has 2 sets of opposite sides parallel to one another. And that's what makes it a parallelogram. And the second you recognize that it's a parallelogram, you know a lot of stuff, like the stuff I just mentioned a minute ago. So let's take a look at this problem. So it looks like there's a diagonal running through, and what we want to find is the measure of angle 1, which is here, the measure of angle 2, which is there, and the measure of angle 3, which is there. Now, I'm not really sure what 1 and 2 are yet, but I know the measure of 3. And here's how I know. Because this is a parallelogram, I know that opposite angles are congruent. And so if this angle here is 90 degrees, then angle 3 must also be 90 degrees. And so all of a sudden I can get measure of angle 3. Sometimes you don't want to start with the number 1 and then work to number 2. Sometimes later on, like 3 is more obvious, and so that's why I started there. Now, another thing I know about parallelograms is that consecutive angles are supplementary, which means that they add to 180 degrees. So if the angle marked 3 is 90 degrees, then this angle with the 39 degree as part of it is also 90 degrees, correct? That's going to be helpful here in just a second. Another thing we know, and this goes way back, is that if you have 2 parallel lines, that's terrible, and a transversal, you know that alternate interior angles are congruent to one another. That means that the measure of angle 2 is 39 degrees. Alternate interior angles on parallel lines are congruent, and so 2 is 39. Now the way we're going to get 1 is that since this angle that's marked 39, the whole thing is 90 degrees, then so is this one here. And if we know angle 2 is already 39 degrees, then all we have to do is subtract 39 from 90 to get the measure of angle 1, which is going to be 51 degrees. And that's done. Nothing but theorems here. First, we use the opposite angles on a parallelogram opposite angles theorem. Then we used alternate interior angles theorem. We used the parallelogram consecutive angles theorem to find the measures of these angles. We're going to be doing essentially the same thing with the figure on the right. Let's see. Well, same idea here. If this angle that's marked 125 is in a parallelogram, which it is, see that? Then we know that this angle over here is also 125 degrees, which is good stuff. Because then I know the measure of this angle, this whole thing. Because I know that in a parallelogram, consecutive angles are supplementary. In other words, those 2 angles should add to 180 degrees. So if I take 125 and I add to that the 22 that's in that angle, and then I add to that the measure of angle 4, which is the other part of that green angle, I should get 180 degrees. That's what it means. Consecutive angles in a parallelogram are supplementary. And now it's just a matter of kind of working through the math. I don't have a calculator handy, but you'll forgive me, right, if I don't know what I'm doing a little bit. So 125 plus 22 is going to be 147, right? Plus the measure of angle 4 equals 180. And I'm running out of room already. So I'll do that. And then I have to subtract 147 from both sides. These cancel, and I'll have the measure of angle 4 when I'm done. Now 180 minus 147, well, let's see. My 180 minus 150 would be 33. So I think we have 33 degrees here. Gosh, I hope that is correct. I would love to check it, but see a calculator around this classroom at all. Weird, huh? All right, so that is that. I actually found one, but now I can't make it work. 180 minus 147. Yes, 33. Okay, good. My confidence was low, and I didn't want to steer you wrong. So the measure of angle 4 is 33 degrees. All right, great stuff. So let's find the measure of angle 5. Well, notice how we have parallel lines, and this diagonal works as a transversal, right? Which means that angle 5 and angle 4 are alternate interior angles. And so they are congruent, which means the measure of angle 5 is also 33 degrees. And then the measure of angle 6, well, it is an opposite interior angle with the one that's marked 22, and so it is 22 degrees. And that warm-up is done. Lots of stuff going on, lots of little pieces to pull together, some theorems from way back that come forward. We never leave anything behind in geometry class, so yay. All right, now's the time to update your notebook, friends. Get a page ready for today's notes, write a summary, write some questions, dig into that notebook a little bit, get into your math brain, and then come on back and we'll do this here lesson. All right, your topic today, properties of special parallelograms. So we're sticking with parallelograms, but we're going to be specializing in some very special parallelograms. Your essential question, what are the properties of the diagonals of rectangles, rhombuses, and squares? Those three objects are the special parallelograms that we're going to be talking about today, and we're going to be talking about their properties. Make sure that topic makes it into the table of contents of your notebook, and let's do this. So we've been talking about parallelograms in general, just kind of what happens with all parallelograms. In other words, if you got a parallelogram, opposite angles are congruent, opposite sides are congruent, diagonals bisect each other, consecutive angles are supplementary. Those are the big ideas with parallelograms. So this is true for these guys as well. But now there are some special things that are true about three special parallelograms, the rhombus, the rectangle, and the square. In order to study these, we got to know what they are. A rhombus is a quadrilateral actually, I'm going to change that. A parallelogram with congruent sides. Wow. So all the sides of a rhombus are congruent to one another. In a rectangle is a parallelogram with congruent angles. The reason why all rectangles have 90-degree angles is because in order for a rectangle to be a rectangle, it's got to be a parallelogram with congruent angles. Well, all four of a rectangle's angles have to be the same, and they have to add up to 360 because that's true of all quadrilaterals. And so in order for that to happen, you take 360 divided by 4, what do you get? You get 90. And that's why a rectangle has all four angles measuring 90 degrees. Now a square combines these two things together. A square is a parallelogram with all angles and all sides congruent. So if you take the idea of a rhombus and a rectangle and you squish it together, you get the square. So those are the definitions of those objects. And we're going to talk about things that are true, properties of these particular objects. But to understand these special parallelograms, we're going to use a new idea. It's called a corollary. Now, a corollary is very much like a postulate or a theorem. They tell you what is true about a thing, and it's an idea you can use just like you would with a postulate or a theorem to create equations and calculate with them. A corollary, the definition of a corollary, and you don't have to have this in your notes, I just kind of wanted to explain the language to you. A corollary is an idea that follows logically from another idea. Another way to say this is that it's a result. Just sort of a natural thing that happens because something else is true. It's okay that you don't, it's postulates, theorems, and corollaries are basically just truths, things that are true. And that's really all you need to worry about with them. There are subtle differences, but I didn't want you to get confused by the language because we're going to be talking about the rhombus corollary, the rectangle corollary, and the square corollary. And these you're going to use them no differently than you would use a postulate or a theorem. They're just called corollaries, and I didn't want you to get confused. Now, the thing that's cool about these three corollaries is that they are very much like the definitions we just talked about. Here's what I mean. The rhombus corollary looks like this. A quadrilateral is a rhombus if, and only if, it has four congruent sides. Now, for note-taking purposes, I would pause the video and write that down, just like you would a theorem or a postulate, because you're going to need to use it. I'm not writing it all out because I sort of don't want this video to be, 10 hours long. So pause and write that. And then the rectangle corollary. A quadrilateral is a rectangle if and only if it has four right angles. So you can see how these aren't super different from the definitions. They're just a little bit more specific about what's going on with these objects. And then the square corollary, again, write these corollaries down. A quadrilateral, if it is a square, if and only if it is a rhombus and a rectangle. So basically the same idea as the definition, but a little bit more specific. These three corollaries are the corollaries that we're going to use, very much like theorems, to calculate some ideas. So go ahead and pause and write these down, and then come on back. So this is also not really necessary for your notes, but I just kind of wanted to show you the relationship between parallelograms, rhombuses, rectangles, and squares. So in this big outside rectangle that's not shaded, it's parallelograms. In other words, all objects that have opposite sides, where opposite sides are parallel. And this is true of parallelograms, so this guy right here and this guy right here. But it's also true of everybody else. All rhombuses are also parallelograms, they're also squares, and they're all rectangles. So everybody that's called a rhombus, a square, and a rectangle is a parallelogram. They fall in that category. But then there are some parallelograms, like this one and this one, that are not rhombuses, squares, or rectangles. Now, rhombuses are very clear that they need to have 4 congruent sides. And then rectangles have 4 right angles, or 4 congruent angles. It is the square that combines those two ideas. They are both rhombuses and rectangles at the same time. So this diagram kind of helps us pull apart the differences between just regular old parallelograms, rhombuses, rectangles, and squares. Again, it's not necessary for your notes, but I thought it was kind of interesting. So there you go. So let's take these ideas and let's calculate a little bit. Let's wrap our heads around them. So for any rhombus, QRST, decide whether the statement is always or sometimes true. So let's take a look at part A. It says to draw rhombus QRST. Now it looks like QRST will apply to both problems A and B, so I'm just going to go ahead and draw this rhombus. And it's terrible. But as soon as I do this, it's a rhombus, friends. It doesn't have to be pretty. I have marked those sides as congruent, and so they are. And then I'm going to label it QRST. There we go. Now, is it true all the time that angle Q is going to be congruent to angle S? And the answer is yes. And the reason why we know this is because of the parallelogram opposite angle theorem, which says in all parallelograms, opposite angles are congruent. And since rhombuses are parallelograms, the opposite angles will be congruent in rhombuses as well. What about Q and R? Is this angle congruent to this angle? Well, certainly not always, because some rhombuses aren't squares. And so there's going to be some times that you don't have congruent angles at Q and R. In fact, if it's kind of leaning over, like the sort of like this one, let me go back to this, like this one. You can see that these two consecutive angles are not going to be congruent. But there is a particular type of rhombus that will have congruent consecutive angles, and it is called a square. And so on this one we could say, we'd have to say always on this one, huh? Sometimes on this one. And that sometimes would happen when the rhombus is a square. That's when you would have Q and R be congruent to one another. All right, let's try another one. Classify the special quadrilateral, explain your reasoning. Well, what I see is a quadrilateral, 4 sides. I see that all 4 sides are congruent to one another and nothing about the angles, and so it would appear to me that this is a rhombus right here, something like that. Now notice also that this angle here is 70 degrees, and so it's clearly not a square, because a square has all 4 angles 90 degrees. It's not a rectangle. Well, it can't be a rectangle because all 4 sides of it are congruent to one another, and so this one must just be a rhombus. Okay, you see how that works? So just kind of looking through and finding what's true and pulling out the classification of that quadrilateral. There was a typo in this question, so I changed it, but it says, for any square JKLM, is it always or sometimes true that JK is perpendicular to, that's what this means, perpendicular, in other words, 90 degrees. Explain your reasoning. So this is another time when this Venn diagram might come in handy for us. So let's draw this square. Now I don't know if that's a square or not, but if I do this, then it is. I don't have to measure anything. If I mark it that way, then it is. And it's called JKLM. Let's see, is it always or sometimes true that JK is perpendicular to KL? Well, that's going to be always true. And that's because all angles are 90 degrees. That's going to happen in every square. So yeah, that's going to always be true. For any rectangle EFGH, is it always or sometimes true that FG is congruent to GH? Well, we might not need this Venn diagram. We didn't really need it in the last one, but we'll see. Let's draw our rectangle. It's really the drawing that is most important for these to visualize this. Now in a rectangle, we've got this going on. That's all we really are talking about. So is it always or sometimes true? Oh, we have to label it EFGH. FG congruent to GH. Well, it's not always true, is it? Because in a rectangle, that side FG could be shorter than GH and vice versa. But there's a special type of rectangle where it could be true, and that special rectangle would be a square. And so this one is going to be sometimes. And that would be when the rectangle is a square. Because squares can be rectangles, but rectangles cannot be squares. Am I blowing your mind? I know. All right, a quadrilateral has 4 congruent sides and 4 congruent angles. Sketch it and classify it. Well, let's see. It's a quadrilateral, so I'm just going to throw down 4 sides here. 4 congruent sides, boom, 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 boom. 4 congruent angles. Well, if it's a quadrilateral, all 4 angles have to add to 360, which means that each one of these angles is going to have to be a 90-degree angle. And what does that look like when we're done? Let's take a look at our possibilities. The only object that it looks like is the square, and so this is a square. Just following the directions of the problem and classifying that quadrilateral from our pretty handy Venn diagram. All right, y'all. That's it. You're going to be classifying special parallelograms. Next video is going to be about some more theorems about special parallelograms. Yeah, so I hope you enjoy. If you need any help, please do let me know. Bye.